We're looking at the derivation of distance covered in n second. So we'll start off with our algebraic method. So we have a particle moving from point A to point B. So we can call this as when time t is equal to 0. And the object is somewhere over here at t is equal to n minus 1. And this is where the object is at t is equal to n. This is the displacement. This is the displacement of the object at nth second. So this is the funda. This is what we are looking at. We are trying to calculate this value. So to this point, from the starting point to this point, from this point to this point, and from this point to this point, it is the distance that the object has traveled. Sn minus 1, and this is Sn. And that's that. Okay, so this is the entire funda. So this is the entire picture. So we need to move forward with this. So first thing first, the distance the object has traveled in first t second. So what is the funda over here? We'll just figure out what is the distance the object has traveled in general and substitute the n minus 1 and n and subtract them. As simple as that. Right? We are trying to get a general expression. So this is nothing but your s, say t. This is how we can represent it as. So v naught t plus half at square. This we already know of. Now we'll go case by case. This is what I was talking about. Distance traveled in first n minus 1 seconds. So this will be Sn minus 1 v naught t plus half. Oh, sorry. In place of t, we are putting n minus 1. Half a n minus 1 square. And similarly, what do we have? Distance traveled in n seconds, not n second, n seconds. So same thing. So we have Sn is equal to v naught n plus half a n square. Now we're going to substitute, or not substitute actually, we're going to subtract. This is 1 and this is 2. So 2 minus 1. Right? That's how we'll be able to move forward. So if we do that, we'll end up with Sn minus 1, which is equal to v naught n plus half a n square minus of v naught n minus 1 plus half a n minus 1 square. So this is just a matter of rearranging, and we have v naught n plus a n square by 2 minus v naught n plus v naught. Okay, I'm doing a bit of math over here. Minus an. Oh, we need to expand that as well. So we have minus a by 2 n square plus 2n, oh sorry, minus 2n plus 1. So let's see if anything gets cancelled. Yes. So we have this and this getting cancelled. And a n square by 2 and a n square by 2. So this also will get cancelled. And that's it. So we basically have s nth is equal to v naught plus a by 2 2n minus 1. Again, I did a bit of math over here. So this is the final expression. So all this algebra and arithmetic part, it's left to you guys to do it. Just a second. Yeah. So that's that. Okay, so this is your algebraic method. Now let's look at the calculus method. Method 2 using calculus. So we know that velocity as a function of time is given by ds by dt. Very simple and straightforward. But ds by dt is also equal to u plus at, because that's another expression for your velocity. Or I can write therefore ds by dt is also equal to u plus at, right, as v of t is equal to u plus at. Again, it's left to you guys how you want to write all of this across. So to find the distance, find distance covered in nth second, so what can we do? We can consider t for t is equal to n minus 1 to n, or we can integrate. Let me write it that way. Actually, we need to rearrange this. Let me rearrange that first before writing this statement. So ds can also be written as u plus at dt. Now find the distance covered in n second. Yeah, now it makes sense. Integrating both sides. So we have ds is equal to integrating u plus at dt. So for nth second, distance covered, time will be what? T will be equal to, or initial time will be equal to n minus 1, and final time is equal to n. And ds is nothing but your, therefore s nth is equal to, this will be so. There's no other option. It has to be so. This is integrating n minus 1 to n u plus at dt. Right? So on integrating, you will end up with ut plus at square by 2, and we have to substitute n minus 1 and n in place of t, that is. So we have a bit of a calculation. N minus of n minus 1 plus the same set of calculation actually. A by 2. So we need to subtract n square and n minus 1 the whole square. So this and this will get cancelled. So we have this to be u. Okay, let us continue this. Plus a by 2. When you expand this, you have n square minus n square plus 2n minus 1. So this and this will get cancelled. So we have u plus 2n minus 1. Is this the same expression? Yes, we have the same expression. In place of u, you can substitute v0. That's the only thing that I thought I should change, but you guys can do that, right? So instead of v0, you can write it as u. That's it. If not, we have the same answer. So what is that we looked at? We looked at deriving distance traveled in nth second using algebraic and calculus method. So it's quite simple actually. It's commonsensical. All we have to do is how much distance has the object traveled from time t is equal to 0 to n and from time t is equal to 0 to n minus 1. If we find that individually and then go on to subtract that and simplify, we'll get the answer. So indirectly we are doing the same thing over here as well, just that we are using the art of integration. Okay, so when we integrate it from certain limit to n minus 1 to n and substitute it, so on and so forth, we end up with the same answer. So any math part over here, if you are not able to get, so please pause, think over. Yes, I have skipped few steps because you guys are in that grade that I should not be wasting time for either of us. So you should be able to do it is what I mean to tell.